أهلا وسهلا فيكم. سعيدين برسائلكم وبمشاركتكم، وعليكم السلام ورحمة الله وبركاته. في ناس عم بيكتبوا لي الصوت، أعتقد إنه الصوت واضح وأمورنا تمام. الحمد لله تمام، يعطيكم ألف عافية. سننتظر دقيقة أخرى ومن ثم نبدأ. Good evening everyone, because we are starting to receive some English messages. So good evening, good afternoon, good morning for everyone. We will be starting in a minute, please. Just waiting for more people to join. جميلة أسئلتكم وحماسكم ونشاطكم. لا، حنجاوب على كل الأسئلة ورح نوضح كل شيء بإذنه تعالى، بس أعطونا دقيقة واحدة، تنتهي الدقيقة وسنبدأ فورا. شكرا لأسئلتكم عن الشهادة وعن كل شيء، هلأ رح نوضح لكم كل التفاصيل. اسمحوا لي أن أبدأ الآن. أسعدتم مساء وأسعدتم صباحا أينما كنتم في هذا العالم الذي بات صغيرا بفضل وسائل التواصل والتكنولوجيا. نطل عليكم مرة أخرى من خلال جلسات التعلم التي تقدمها أكاديمية الملكة رانيا لتدريب المعلمين ضمن سلسلة QRTA TALK، وحيث تستمر مسيرتنا وإياكم لهذا العام 2024. نبدأ أولى جلساتنا مع موضوع شيق وملهم وجميل عن النمذجة الرياضية أو الماثماتيكال موديلينج. جميعنا معنيون بتقديم أفضل أساليب التدريس لطلبتنا، ومن أهمها أن نضع بين أيديهم أساليب التطبيق الحقيقي لما يتعلموه داخل الصفوف الدراسية، مما يعزز لديهم التفكير النقدي ومهارة حل المشكلات، وهو فعلياً ما نصبو إليه جميعاً. ضيفتنا لهذه الجلسة هي الدكتور ألين صغير عباسيان، حاملة لدرجة الدكتوراه في علم الرياضيات، باحثة ومحاضرة في أحد الجامعات الأمريكية. دفعها شغفها وحبها للرياضيات لتقديم الكثير من الأبحاث والدراسات والتعاون مع الكثير من الجهات في تطوير وتطبيق النمذجة الرياضية والتكنولوجيا. بعد ما حييتكم بالعربي، رح اسمحوا لي إني أنا أحيي الأودينس اللي معانا باللغة الإنجليزية. Good morning, good afternoon, and good evening, everyone. Our greetings to you wherever you are in this small world, where QRTA is bringing us all together during QRTA Talk. We are continuing this journey with you and will be starting this year, 2024, with this extraordinary session about mathematical modeling and how it can ignite critical thinking for our students. Our guest, Dr. Aline Abassian, we will be having the opportunity with her to explore the fascinating world of mathematical modeling, where mathematics meets real-world problem to provide solutions, insights, and predictions. Mathematical modeling is a powerful tool used in different fields, from physics and engineering to economics and biology. In this session, we will explore the principles, applications, and challenges of mathematical modeling. And we will hear our esteemed guest who will bring diverse perspectives and expertise to the discussion. Dr. Aline Zghayar Abassian is a mathematics teacher educator. She works with prospective and practicing teachers at the elementary, secondary, and post-secondary level. Her teaching experience inspired her research focus of examining mathematical knowledge of teaching and using mathematical modeling and technology to foster equitable student learning of mathematics concepts. Her scholarly work includes research grants, numerous peer-reviewed presentations and publications in international, national, regional conferences and journals, and extensive service to professional organizations and educational institutions nationally and internationally. Before I leave the mic to Dr. Aline, allow me please to remind you with 3 notes. First of all, the translation will be available for this session directly. Just you need to click on the globe icon and choose the language to see the translation. Regarding the second point, regarding the certificates, they will be issued directly after the end of the session and they will be sent to the email that you used for registration. Finally, and point number 3, we will be grateful, QRTA team, if you click on the feedback link provided after the session, because your opinion is very important to us. So please click on the link and fill your feedback. 3 نقاط بدي أذكركم فيهم بالعربي إذا سمحتوا لي قبل ما أترك المايك مع دكتور ألين. النقطة الأولى، الترجمة الفورية رح تكون متوفرة لهذه الجلسة، بس ما عليكم إلا تضغطوا على أيقونة الكرة الأرضية وتختاروا اللغة المناسبة اللي بدكم تسمعوا السيشن فيها أو تشوفوا الترجمة الفورية تبعتها. النقطة الثانية، شهادات رح تكون متوفرة للمسجلين وسترسل عبر الإيميلات اللي قمتوا بالتسجيل من خلالها بعد نهاية السيشن. النقطة الثالثة والأخيرة، رح يكون في تغذية راجعة، رابط للتغذية الراجعة في نهاية الجلسة موجود أمامكم. رح نكون ممنونين إحنا وكل فريق ال QRTA لأنه رأيكم بهمنا وبنحب إن نسمع منكم دائما، فأرجوكم بنهاية الجلسة إنكم تعبوا الرابط تبع الخاص بالتغذية الراجعة. شكرا جزيلا لكم، شكرا لدكتور ألين ولصبرها لأني أنا يمكن طولت شوي. بترككم هلأ مع دكتور ألين. You are most welcome دكتور ألين and the mic is yours. تفضلي. أهلا وسهلا فيكي.
Thank you so much. Thank you, Hala. Hello, everyone. Good evening. It is my absolute pleasure to be here with you today. Good morning or good evening. Like I said, here it's morning for me, but I know we're all over the world. So I hope you are all doing well. I hope the next hour or so that we're spending together will be beneficial for all of us. I am very excited, very honored to be in this space with you and to talk about mathematical modeling and how it can be used by us educators to help our students develop critical thinking, and how it can also be used as a catalyst for change. So as we begin, I'd like us to think of this scenario. As a mathematics teacher, as a previous math teacher, I can relate to this. I hope you can too. We've spent so many hours preparing lessons. We think of engaging activities. We think of games, maybe puzzles, discussions to share with our students. And then we hear this question. We hear the question, when are we ever going to use this? This is, I feel like as a mathematics teacher, I was always dreading this question when I got it in the classroom. So as a result, some of us think, how can I make my math lessons more relevant to my students? How can I have them see how important mathematics is? Because as math teachers, we know the importance of math, but how can we help our students see the relevance of mathematics? But I have a challenge for us all. Instead of just asking our question of how can I make math relevant, I want us to think of this question. How can we create an educational system in which the problems our students see in school, in our classroom, actually reflect the authentic and messy problems that we always encounter in life? So with that, let's go ahead and continue with our session objectives. Today, we are going to discuss the current state of mathematics education. We're going to look at, what we see in our classrooms these days. We're going to reflect on how mathematics can help us analyze and guide decision-making for authentic, messy word problems. We're going to describe the mathematical modeling process, its components and requirements, and we're going to provide some strategies for integrating mathematical modeling tasks in the classroom. So a lot of the times when I think of some students' experiences with mathematics, sometimes this picture comes to my mind, this visual. Our students sometimes see math as disconnected islands, perhaps deserted islands that nobody lives there because they can't see the relevance. They're like, no way anyone uses, these topics that we're learning about. Sometimes they see it as there's algebra island, and then there's geometry island, there's arithmetic island over there. I used to be there a long time ago. And it's usually not bridged or connected with, what they see in real life. And as a result, many of our students don't see the value of mathematics. But we can help empower our students. We know that mathematics can help our students by expanding their professional opportunities. We know that as their educators. We know that teaching them how to analyze, teaching them mathematics can help them analyze and critique the world around them. We know that mathematics can help them experience the joy and wonder and beauty that is all around us. So why do we teach mathematics? Again, how can we help our students see all of the, great things that we know about mathematics? We can't help them see all of these wonderful things that we talked about if mathematics is taught without addressing the relevance to their lives, without helping them connect how mathematics can actually enrich their everyday life. So when we use context to teach mathematics, this question is no longer on us as teachers to answer. So it's not when the students are using the context, now they're going to answer the question that I posed earlier. When are we ever going to use this? Now they're going to answer it themselves. It's on them now to answer it because now we're providing the context and they're using the mathematics to solve it. And so students begin to see the natural connections that mathematics has with all the other disciplines like science, social studies, language, the arts, and technology. So how? There's lots of different ways we can do this, but today our session is going to focus on mathematical modeling. Mathematical modeling is something we all use inside of school and outside of school in our everyday life. It's when we use mathematics to answer big, messy, reality-based questions. So when I say mathematical modeling tasks, these are tasks that are open, they're authentic, they're problematic, they're not straightforward, but students can still access them. So they're not too complex that they can't understand them. They allow for creative solutions and they are iterative. That means we can think about them over and over and change our answers.
If you allow me, Dr. Aline, to ask a question here, please. From what you are explaining now, maybe we can think that the mathematical modeling is somehow look like the problem solving or the common problem solving that we used to use in math or in physics, in chemistry. So can you tell us how they are different, the mathematical modeling from the regular problem solving that we are using?
Excellent question, Hala. So mathematical modeling is not like what we think of as a word problem. We're going to talk about what are some of the different types of mathematics problems, so problems we maybe use in our classroom, and how is mathematical modeling a little different than that. So let's start with a general math problem. So maybe that can be an equation, right? So it could be something like solve this linear equation, 2x plus 6 is equal to 14. That is a general math problem. Now, if we take that and add some words around it or add some labels, it becomes a word problem. So notice here, instead of 2x plus 6 is equal to 14, if I want to make a word problem, I might say something like this. Noor has 2 bags of marbles instead of the 2x. Her friend gives her 6 more marbles instead of the plus 6. Now she has 14 marbles. How many marbles are in each bag? So notice here, it's still the exact same thing. I just added some labels, and this is called a word problem. Now, if we take that and add some meaning, maybe put this in a story, it becomes an application problem. So now maybe we surround it with Noor and her friend are playing with their marbles, right? Noor brought 2 bags of marbles. Her friend brought 6 bags of marbles, or 6 marbles, excuse me. And then they combined their marbles, and now there's 14 altogether. And then the question might be, how many marbles did Noor bring? So now it's the same equation, it's the same mathematics, but different types of problems. But all of these, none of them are actually mathematical modeling problems. Now, what makes mathematical modeling different? What makes it, special? Is when we take that and we add interpretation. We take that and we let the students come up with some of the constraints. So here's an example. You and your friend want to play with marbles. How many marbles should each of you bring? But I want you to justify your solutions mathematically. Notice here that the students have to make choices. They have to input their own interpretation. They have to think of what's fair. They have to think of what game they want to play. So there's a lot of choices that they're making. We're going to talk a lot more about mathematical modeling and tasks and all of that. But before we get into it, I want us to look at the process of mathematical modeling. So when we're solving a mathematical modeling task, these are the steps that we're going through. We start with a contextualized situation. So it doesn't start with a question. It starts with maybe a situation that we've thought about. Then from that, we can think of a question, a real world question. And then we take that and we mathematize it, and it becomes a math problem. And then we solve the math problem, we get our math solution, and then after that, we have to take it and put it back in the contextual situation that we started with, and then communicate our solution. We can use, presentations, we can write about it, we can do a poster about it, but this is the cycle. And again, we'll come back to this when we do a specific task. So again, going back to Hela's question, what makes mathematical modeling different than all the other types of math problems that we might be used to? The students are engaged in making choices about how to use the mathematics to create representations of the real world scenario that they encounter. Students are provided with experiences, and that helps them foster joy and satisfaction that comes from creative work. So we're making mathematics a creative, a creative process. So with that, I'm going to go ahead and pose this situation, and I want you to think about it. I feel like there are always 2 types of people. People that think, for better deals, I will drive wherever I need to. I will drive really long to get a better price for a product that I'm looking for. But other people would rather just go to the closest store next to them. They prefer convenience, and they are happy to pay a little bit more as long as they don't have to drive a lot. So right now, I'd like you to just reflect. Which one are you? Are you the person that will drive longer for a better price? Or are you the person that just wants to get to the closest store and are okay with paying a little bit more? For me personally, I'm not a huge fan of driving, so I will go to the closest store. But I know, for instance, my
If
mother,
you allow me, Aline,
Go
just to
ahead.
read some of the answers.
Yes, please do.
Most of the answers I'm receiving here, they are choosing the closest one.
So a lot of people are like me, and they don't want to drive. I know with Amman traffic, that can be why sometimes.
Exactly. So you are aware of the disaster we are facing here.
No, Amman traffic is I cannot complain. It is always entertaining for me. But I do have to say, my mother, for example, she will drive wherever she can to get those better deals. So, there are lots of people that will drive the extra few kilometers or multiple kilometers to get the better price. So this is a situation that I think all of us encounter in our everyday life. We might be thinking, I know this store sells it for cheaper, but I really don't want to drive there. Let me just stop here. Or maybe you're like, no, it's too much. It's too expensive. I'm just going to drive a little bit longer. So this is a situation that's very relevant and it's natural. We don't think about it as a math problem. It's a natural everyday situation. So that's the context we're in. Now, if I take that and I create a math problem out of it, or a real world situational problem out of it, it could be something like this. We know that food prices change often, and not every store offers the same price for your favorite coffee, right? Now, the store with the cheapest prices may be across town from where you are right now. Is it worth the drive across the town to get that less expensive coffee? And so a possible question I can ask you is create a mathematical model that could be used to help understand what conditions it is to make the drive. So I'm forcing you to think about like, no, we are going to drive. You tell me what's a possible mathematical model to help us understand under what conditions that is helpful. So going back to the cycle here, notice how I started.
Dr. Aline, can you just ask a question here? So what you
Yes,
are saying, if I want just to make sure that we are understanding what you are saying, it means that we are changing any situation to push the students to take a decision and make an interpretation for the information that we are giving. It's not only solving and getting a final answer.
exactly. That's exactly what I'm saying. So we are taking a situation that they maybe think about, that's very relevant to their everyday life, and we're asking them to interpret it mathematically, and we're asking them to, make choices, make decisions about it. So in the driving problem that I posed earlier for everybody, I started with the map, if you notice. That's the contextualized situation. It wasn't really, it was just a context. But then when I gave you this problem right after, that is the real world problem. So it comes from the situation that we may encounter in our everyday life. And so now, if we had time, I would give you maybe lots of time, because this requires time, right? To create this mathematical problem. So now that we have this, how can you mathematize it? Right? How can you use math to help you? Maybe you're going to need distances. Maybe you're going to need speed. Maybe you're going to need, you have to think of all the mathematical things that you need to help you make sense of this. But I want to bring it back to our students. So the problem I shared with you earlier with the coffee, that was really more for us as teachers or as adults, because that's relevant to us. We drive, we buy coffee, but that may not be too relevant to a student. So I changed it a little bit to a possible student problem statement. So it can still be, would you rather, walk longer? Maybe they don't drive yet. Would you rather walk longer to get less expensive candy, or would you rather, find the closest store, maybe pay a little bit more for the candy and then go home? Okay, so that can be the situation. And I also edited the problem statement here to suppose you walk to school every day, and on the way you take from home to school, there are several stores. The prices on your way are always high. They're always very expensive. But you have a friend and she tells you that she buys her candy at the store that's a little bit far away. It's several kilometers away from the normal way. And their prices are a lot cheaper. And then the question is, would it be better to walk the extra distance or, and support your argument mathematically? Notice, I just want to quickly note here the difference between this and the one I shared with you with the coffee, because again, the whole goal of mathematical modeling is the relevance to the students, the relevance to the audience, right? The relevance, if it's adults, we're driving, we're drinking coffee. Students might be walking and buying candy. So we have to make that, that change when we're thinking about the problems. So
Dr.
here are
Aline,
some, go
Dr.
ahead,
Aline,
Ellen.
I'm so sorry just for interrupting, but because I'm receiving a lot of notes about translation, so I just will repeat again. الترجمة متوفرة، عليكم بس الضغط على أيقونة الكرة الأرضية اللي موجودة أمامكم وتختاروا اللغة، لأنه الترجمة فورية ومتوفرة من بداية المحاضرة. شكرا لكم. Thank you, دكتور.
Of
تفضلي.
course, thank you, Hannah, no problem. So I was sharing some tips for students. So when I give my students a mathematical modeling task, I always tell them this. So I give them, because sometimes it can be frustrating. We know when we're solving problems as adults, it's very frustrating. So you know, it can also be very frustrating for our students. So this is just some helpful tips I give them. Start with a simplified problem. So take the complex problem and simplify it a little bit. I remind them the first model is rarely our final model. Focus on what you want. Be conscious of the decisions and the assumptions you make. I always ask them, ask the question, what if? Like, for example, what would happen if a number changed? What would happen if an assumption changed? What questions are we trying to answer? How can we measure that? So those are some helpful tips for our students so they don't get discouraged and give up on the problem. So going back to the candy problem, maybe helping our students get to a simplified version of it. So maybe something like this can be a simplified version. Suppose there is a store on your normal route that sells candy for 3 dinars. A store that is about 1.2 kilometers away sells the same candy for 1.75 dinars. Should you travel the extra distance to buy the cheaper candy at the far away store? So again, this is a simplified version. This is a mathematized version of the real world problem. If they're still having some trouble with it, I always advise them to draw a picture, draw a diagram that can help you. So again, this is for the simplified version that I shared with you. So if this is my home and this is the school, my walk to school, the close store is, store A, it sells it for 3 dinars. If I take a detour and I walk a little bit longer, it sells it for a little bit more. Store B sells it for a little bit more. So those are some tips for students to, support them, to encourage them as they're thinking about the task. Again, we know that I always remind them, our first model is never or rarely the final. We have to, analyze and adapt, analyze and change. And then remind them that their diagrams and simplified problems may need to change because the real world configurations differ. Sometimes we can think of, like the total costs. Is someone going to be able to drive us to the store instead of walk that day? What time does the school start? What time, do I leave my house? What time do I have to leave my house to make it, at school on time? How fast I walk may be very different than how fast my friend walks. And again, like I said, can somebody drive us to the faraway store? So they have to think about a lot of consideration, and based on their considerations, their model will change. So going back to this cycle, we start with the contextualized, we go to the real world problem, they think about it mathematically by simplifying it, by drawing pictures, they come up with a solution, but it doesn't end here. Like Hala mentioned earlier, mathematical modeling questions are not about the answer. They are about how well they can analyze, communicate, and defend, validate. So once they have their solution, they're going back and going to the contextual situation and they're going to analyze it. They're going to say, okay, when I take these consideration, it's better to go to the closest store. When I take these considerations, it's better to go to the faraway store. and then they can communicate by maybe creating a poster or a presentation or, writing about it, a letter or something. So there's always that product and communication piece that's critical for mathematical model.
Thank you so much for now. Let us move to the next idea that might everyone is thinking of. If I'm a KG teacher, I'm teaching kindergarten or grade 1 or grade 2. Is mathematical modeling applicable for me as a teacher for this stage, or it's only special for higher grades? If you
Yeah,
can
I think
tell us.
absolutely, Hala. I think a lot of, I bet I can't read the comments yet. I don't have chat open or Q&A, but I bet a lot of
Yes,
a
a
lot
lot
of
of the
you are
questions are
thinking
about
that.
this, yes.
Yes, like I can see how this will work really well maybe for the upper grades, but what about the, the younger kids? And in fact, all students in K-12 can be engaged in mathematical modeling tasks. All of them, from kindergarten all the way to, post-secondary, because mathematical modeling is a natural human curious thing. So we develop it over time. So I'm actually going to share for each, grade band what we can focus on to help develop mathematical modeling skills in our students. So we'll start with the early elementary grades, like Hala mentioned, the kindergarten, first and second grade. What can we do as teachers to help them develop this type of thinking? The first thing is the central question, unlike, the upper grades, has to be selected and articulated by the teacher. It has to be said by the teacher because they're too little to, make up their own questions. But what we as teachers are going to capitalize on, we're going to capitalize on their ability to compare. I have more, I have less. They're very good at that. Trust me, my daughter is in first grade and she always, my brother has more. That's not fair. I think we can all relate to that. They're very good at that. They can make one-to-one correspondence. They can act out situations. So the big idea in the early elementary grades is that students learn how to frame, explore, answer real-world questions using mathematics. So we're developing the foundation. Now let's go on to the next grade band, which is the upper elementary grades, grades 3 to 5. Now students can think of extreme cases. What happens if I make something really, really big or really, really small? How is that going to change, the logic? They think of hypothetical situations like, what if I do this? They are a little bit more logical. They can think conditionally. What depends on what? The big idea in this grade band is now we can move beyond descriptions like we did in K2. We can move, they can make more assumptions. They can think of more variables. They can construct and actually challenge their models. Does this doesn't always make sense. This only makes sense when, etc. So they are, developing some higher skills in those grades. Now we get into the middle grades, like grades 6 through 9. Now we can capitalize on our students' ability to be more independent. They may not always need you to support them, for every little step. We can create more sophisticated arguments. There are several constraints they can think about. They can use variables for quantities. They can provide multiple representations. So it's not, they can draw a graph. They can write an equation. They can communicate written and spoken or typed. And then again, they can analyze the validity of their own work. How is this valid? When is this not valid? And lastly, in those upper grades, grades 10 through 12, now our students know more sophisticated math to help them solve more, think of the situation more complex. So the situation can be the same from kindergarten all the way to 12th grade, but the constraints and the models that they use will be a lot more complex in those upper grades. They can investigate complex problems with more variables. Technology can help them at this point understand the idea of sensitivity. So, you know, how sensitive a model can be. So again, it can become a lot more complex. So as we, you know, as we are thinking, that's a lot of what the students are doing. Now let's talk about what us, the teachers, are doing. As our students are solving these tasks, as our students are doing the hard work, the mathematizing, the heavy lifting, really, what are we doing as teachers? As teachers, when our students are posing questions, we're helping them organize those questions, maybe writing them on the board, maybe putting them in a PowerPoint. As our students are building solutions, we're walking around, we're watching, we're monitoring, you know, the mathematics that they're using. As they're validating their conclusions, we're asking them, you know, to regroup. We're asking them to go back and think of the contextual situation. And some helpful tips as somebody that has been doing mathematical modeling with students for a really long time. Our goal as teachers is to support the students as they struggle through the math problems. And struggling through math problems is a good thing. We don't want, because that's how they develop, that's how they learn the mathematics. Our job is to lessen their uneasiness through communication. We don't want them to shut down and stop. So we're going to lessen that by communicating. We're going to ask questions, probing them and offering encouragement. We're going to help them learn to accept uncertainty. And then we're going to refrain. It's very hard for us as teachers, but we have to try to not tell them how to solve problems. So a few concluding thoughts as we end our time together. Globally right now, there is a plethora of challenges, of obstacles that we are facing. For example, we are challenging systematic injustices. We want to advance human rights across the globe. We want to combat global climate change. We want to ensure there's food, water, and housing resources for our growing populations. And we want to establish renewable energy sources. There's just some of many. So we need to help our students feel empowered to think of those challenges. We don't want them to hide from those challenges. We want them to feel empowered to think of them and analyze them. So when students are engaged in tasks that require them to question, mathematize, validate, analyze, refine, investigate, those are, by the way, all mathematical modeling steps, they will become empowered to view math as a tool to face those challenges that we're facing. And remember, our students are the problem solvers of the future. Problem solving is a skill that's developed over time. It's not something that, you know, they learn in 1 year. As educators, as teachers, it is very critical that we engage our students in these tasks as early as we can to help them develop those problem-solving skills. And mathematical modeling is one tool we can use as teachers to do that. And with that, I just want to thank you for joining me today. It was great sharing a little bit about how mathematical modeling can not only help our students by developing their critical thinking, but it can also be used as a catalyst for change. Thank you all.
Thank you so much, Dr. Aline, for such great information and some tips and ideas about mathematical modeling, clarifying how it's different from problem solving. Allow me just to make sure for the people who are asking if the session is recorded. Yes, it is recorded, and you can get back to the session on the channel of QRTA on YouTube, and you can get the benefits of all the information Dr. Aline just told us during this session. Dr. Aline, I will take a few questions because we have a lot of questions, a lot of participations. I'm so excited because a lot of teachers and principals are sharing with us how they are using mathematical modeling with different grade level, which is really make us happy about how the teaching of math is changing from the old style and the lecturing style to more inspiring and more creative ideas with the students. Some teachers are asking, can we apply mathematical modeling to connect math with languages?
Absolutely. That's a great question. So, remember when I shared a little bit about when students come up with a solution in mathematical modeling, there's a product, they have to answer it. You can ask them to answer it writing a paragraph or writing an essay or maybe creating a PowerPoint, and you can, specify what you want them, to include. So connecting it to language is absolutely very natural because they have to communicate. And you can, ask them to use their best persuasive argument, or, there's a lot of good connections that can be made between math modeling and language. Great question.
Thank you so much. Okay, for the people who are asking about the certificates or الشهادات، نعم احنا ذكرنا ببداية الجلسة رح يكون في شهادات حضور رح يتم إرسالها على إيميلات حضراتكم اللي سجلتوا من خلالها. Another question, in pure math, such as for proving theorems, how mathematical modeling work? How does mathematical modeling work?
That's an interesting question. So mathematical modeling will always rely on the goal of it is the problem solving, and it always has to go back to real world context. So the focus of it is problem solving in an authentic real world situation. So it is more focused on practicality more than theory. There are, they can mirror each other, and there is, the students are building logical, reasoning skills, whether they're writing a proof in pure mathematics or whether they're solving an authentic real world problem. The focus is, the background, I guess, is that logical, reasoning skills. But I don't see mathematical modeling, being used in theorem and proving theory, because the focus of it is real world situations.
Exactly. Thank you so much. Okay, there's a question I liked also. When do we use the mathematical modeling? Is it at the beginning of the lesson or at the beginning of the unit, during the middle of the unit, or at the assessment level of the unit? Or we can use them on all stages?
It's an excellent question. My favorite way, there's lots of ways. My favorite way of doing it is throughout. So I usually start my lesson with the context situation, right? So it grabs at the very beginning. I give them, something that they can relate to, and it gets their attention, because they may not be able to solve it yet, but at least they know why the mathematics they're about to learn is needed, right? So I start the lesson by giving them the contextual situation. Then, as students think about it, they might be asking you, what math do I need? Like, I can't solve this yet. What mathematics do I need? How can I do this mathematically? And then the lesson is gonna, come naturally, and you can say, well, actually, today we're going to talk about, I don't know, solving linear equations, which is gonna help you actually go back to that question.
Great.
And so I like to do it throughout.
Yeah, so this answer is taking us to the title of the session, Igniting the Critical Thinking. So this way we are igniting the way they are thinking and start to search and find the tool that they want.
Exactly.
Claudia, Aline, and Fayrouz, they are KG teachers, and they are يضموا صوتهم لصوتك دكتور ألين، وبيقولوا إنهم هم عم بيستعملوا somehow they started the mathematical modeling بالKG level، وعم بيلاقوا إنه كتير عم بيفيد الطلاب، وعم بيخلي الحصص تكون ممتعة أكتر، وعم بيثبت المعلومة وبيثبت الخبرة اللي عم بيتعلموها الطلاب بشكل أكبر. So they are starting to use mathematical modeling in the KG department and KG classes, and they found it very useful and beneficial for their students.
Bravo,
okay.
That's excellent. Nice.
Yeah. How can we connect? Let me take, maybe this is the last question we can take. Is there a relationship between mathematical modeling and the way of thinking the students have?
Yes, absolutely. So again, I think I will relate it back to our title of this session, which is it's all about critical thinking. So as they are engaging in the mathematical modeling cycle, they are developing the critical thinking skills. So they're not simply memorizing a procedure. They're not memorizing for this problem, step 1, step 2, step 3, which is, the traditional way of learning mathematics. As they engage in these tasks, their thinking is more, what am I looking for? What can help me? So they're searching for tools to help them solve it. They're searching for math that helps them solve it. So they're more flexible in their thinking. They are more critical in their thinking. So sometimes when a student gets an answer, they're attached to the answer. But if that answer, doesn't really, is not valid when we go back to the contextual situation, they have to restart. So it helps them develop those important problem-solving skills that we usually don't get by just memorizing.
Yeah, thank you so much.
Mhm.
Okay, one more question, Dr.
Sure,
Aline.
go ahead. It's fine.
It's one of the challenges I used to remember I was facing when I was a math teacher,
Sure.
because we think that this kind of teaching will take a time from us and it's time consuming. This is
Yes.
what we think. And we are restricted with the yearly plans and the curriculum that we need to finish. And sometimes the teacher find it difficult to put them all together, so they can finish the curriculum and they can finish the lessons at the same time. They can put it in the mathematical modeling. What can you say about that? What can you give us some tips for the teachers for the time management and applying this, please?
I think that's a beautiful question, because again, as a math teacher, I encountered those as well, having to manage our time. When do we do everything? For me, what helps is you're setting goals. So if my goal is for my students to learn a specific mathematical concept, I can, come up with a good mathematical modeling test, or I can find it, there's lots of resources that will, and I incorporate it throughout. So it's not a one-day thing, right? So I might start it today, we talk about it, and then we can say, okay, we're going to come back to this because today's lesson is going to actually help us answer this question. Let's take a pause on this. We'll come back to it tomorrow. We talk about our math lesson. Tomorrow, we bring the task back and we say, okay, based on what we learned yesterday, now how does that help us answer some of those questions that you couldn't answer? So for me, the task is broken up over multiple days. It's not just a one-day thing. So I'm not, spending hours and hours and that's it. It's broken up so it can, embody the entire unit, not just one day.
Thank you so much. So put it into small chunks or puzzle pieces, and maybe it will take more than 1 week or 2 weeks, and gradually they will start to build the knowledge and build the skills and build the critical thinking channels in their mind, just to put them all together at the end and try to find a solution or an interpretation for the problem that we are trying to solve.
Exactly.
Thank you so much, Dr. Aline. For those teachers and participants who are asking how to apply mathematical modeling in KG or primary schools or the high school, you can just get back to the session again on the YouTube, because Dr. Aline explained and gave a lot of nice examples about each grade level and each age group. Thank you again and again for such an amazing session. I love math, and you just make me love math more and more. Thanks, Dr. Aline, a lot, and we are glad to have you with us in one of our sessions on QRTA Talks, and I hope that you enjoyed it as much as we did.
It was beautiful. Thank you so much, Hala. Thank you, everyone, for a great participation and your engagement. It was wonderful. Thank you.
Thank you so much. Good night. Thank you so much.
Bye, everyone.
Good night, everyone, and thank you for your participation. The certificate will be sent to your email, as we mentioned at the beginning. One more thing, you can follow us on our pages, QRTA in LinkedIn, Facebook, and Instagram, and the website. As well on YouTube channels, you can find all this session and all the other sessions of QRTA Talk. Thank you so much and good night. Bye.